स्विच ऑफ करने के लिए
Hello, good afternoon, sir.
Good afternoon, sir, please.
Thank you for joining. So, good afternoon to everyone. Dear participants, this is the fourth session of 1 week online faculty development program on machine learning, concepts and applications. So, for this session, we have with us Dr. Kiran Siri. He is professor and head Department of Computer Science and Engineering, Shri Vishnu Engineering College for Women, Andhra Pradesh. Dr. Kiran Siri has received his BTech and ME in Computer Science and Engineering from JNTU and Anna University, respectively, and obtained his PhD degree in the area of artificial intelligence from JNTU, Hyderabad. He has authored 6 textbooks for undergrad and postgraduate students of engineering in AI and published more than 100 plus research papers in various international journals and conferences. He has filed and published 6 patents in the area of artificial intelligence and deep learning. His bibliography was listed in Marcu's Who's Who in the World 29th edition in the year 2012 in USA. Professor Kiran is the recipient of Bharat Excellence Award from Dr. G.V. Krishnamurthy, former Election Commissioner of India for 2 times, and recipient of Rashtriya Ratan Award also. He was also the Board of Studies member of Computer Science and Engineering and IT in some universities and autonomous colleges. He also worked as principal of the NBKR Institute of Science and Technology. He has got 18 plus years of teaching and research experience and working as professor in the Department of Computer Science and Engineering at Shri Vishnu Engineering College for Women, Bhimavaram, Andhra Pradesh. He has delivered more than 100 technical talks on artificial intelligence as well as deep learning in various international conferences, faculty development programs, webinars. He is the faculty champion of the University Innovation Fellows Program by Stanford University, US. His research interests include deep learning, big data analytics, bioinformatics, cloud computing, as well as he's associated with various journals as well as conferences in various capacities as editor-in-chief, editorial member, and reviewer. Further, he is the global vice president of World Statistical Data Analysis Research Association. So I welcome you, Dr. Kiran Siri, sir, in the session 4 of 1 week online FDP on machine learning, concepts and application. And thank you so much for sparing the valuable time. And dear participants, sir will talk on the recent advances in deep learning. So over to you, sir. Dr. Kiran.
Thank you. Thank you very much. It was a wonderful introduction. And can we start my presentation, sir, please?
Yes, sir. Yes, sir. Sure, sir. You can.
Can you see my slides, sir?
Yes, sir. It's visible.
And it's really a privilege to be part of this faculty development program. I'm very happy to be associated with this. And as per the instructions of the coordinators, the talk is very simple, like how do you create some ambience, research ambience for people who are aspiring to register for PhD in the areas of deep learning, machine learning, and artificial intelligence. That is how I have made these slides. Because very recently, like I have authored a textbook for Pearson Education on applications of deep learning. Like most probably this month, this textbook is going to be released. And most of the discussion that I have done in this particular presentation will be the summary of the textbook, like what type of applications are there if somebody wish to work in artificial intelligence and deep learning and AI domain. what is the input that we need to take, what type of data sets we need to consider, and what type of strategies are already there, what type of strategies has to be hybrid, and all this discussion. That is what the target of my presentation. And we have a very simple presentation that was made. Like I will basically talk about what is the target of deep learning and artificial intelligence or machine learning. And then most of the emphasis will be on various deep learning applications and what type of applications are there. And if somebody wish to develop a deep learning algorithm, what should be the focus of the people who are working in deep learning. And then we talked about what is the difference between a traditional AI system and what is in a machine learning and what is a neural network system, and why we need to go for machine learning, what are the disadvantages of machine learning, then why we have to go for deep learning, what exactly is deep learning, what are the strategies that we have in deep learning, then we end up with a case study. So it will not consume more than 1 hour 20 minutes. So in generally, when people try to design an AI system or think about an expert system, the target is like, can we design a system which exactly thinks like a human being? Is very difficult objective to be achieved. It's very difficult to design a system which thinks exactly as a human being. So obviously, whenever we try to design an expert system or we are part of an expert system earlier, this objective is a very difficult objective to be achieved. And can we develop systems which can think in the terms of humanly? Can we train the systems which acts like human beings? Is a definite objective that can be achieved. Yes, what you said is right. So can we design computers which act humanly is an objective that can be achieved. So obviously many of the expert systems will fall into this category, second category. Can the computers exhibit some intelligence, or can the computers think rationally and logically without training? Is a very difficult objective to be achieved. And can we train the systems to act logically or act rationally is an objective that can be achieved. So most of our expert system will fall either in second category or fourth category. In both of many of them, like Sophia, will fall in both the second category as well as fourth category. So how do a system, like if somebody asks me what exactly is AI has many definitions, like if you are able to mimic the human nature, or if a system exhibits intelligence, we call it as an AI system. Or if a system try to solve this NP-hard problems, we can say that it is an AI system. But we have many definitions. We have, when AI is indicated to IoT, we call it as super IoT. And very recently I heard this, can we have a system which thinks beyond the perception of a human being? Is a very difficult objective to be achieved. So if you see the list of Gartner's hyperplane, like if you see the trends that Gartner has quoted, artificial intelligence, machine learning, deep learning, all these are, the demand for this will be there at least for 10 to 15 years. And this is how the trend is going on, and now the trend is happening. So we are living in an AI world, and AI is an integral part of this. So intentionally I have kept the slides like this, like we have, I have kept a old AI application, and I have kept a latest deep learning application. Like Deep Blue is an AI system that is developed by IBM. Like if most of the people are aware that we have this tic-tac-toe game, when with two people will play a game like A and B. But see here, when two players play a game, like A play the next instance and B wish to defer the winning of A, something like this. So what will be the strategy of B based on A, and what is the probability that A can win, or what is the probability that B can win, or what is the probability that they can go for a tie? So this is basically a 3x3 matrix, where if you consider a tic-tac-toe game, every time we try to think about what type of a strategy that we need to develop based on the opponent's strategy. The outcomes can be three, because three classes are possible, like A can win or B can win, or they can go for a draw. The same way, deep blue, when we have a system like 8 by 8 matrix is what is the state space for this particular chess game. And there are some there are 16 pieces this side and 16 pieces that side, and they can move based on some restrictions and constraints. So the thing is, like, whenever we try to think about an AI system, we try to have like what type of predictions that we can have. Like if A and B are playing the game, what is the chance that B can win the game, provided the strategy of at least one or two steps of A are known. And what is the winning strategy of A, provided B winning steps for one and two are known. And every time when intelligence, like you have a definition in AI saying that if a system exhibits intelligence, we call it as an AI system. So how can the systems exhibit intelligence? What type of heuristics will make this difference? And what type of intuition that you can embed into the systems is what is the challenge. So based on the steps that A will make and what is the probability that B can have, how many strategies that B can adopt, and all this are prediction. That is what the latest challenge, or whatever challenge it is, like how do you predict the moves of B with respect to A so that B can win. In the right side, I have kept a very advanced version of deep learning application, where you can call Tesla is a company which produces semi-automatic cars like driverless cars and so on and so forth. But what is your interest has to be when we try to design this type of systems? The interest is how does this a particular car can perceive the environment, like how can it understand this, particularly people who are on the left hand side and the right hand side who are on this front and back. How can this perceive the environment? How can it process the horn? Like how can it perceives this voice at real time? And if you see the various functionalities of Tesla, you have something like it has cruise control, it can have self-parking. So what type of parking space is available, and what is the amount of space that it needs? And if how can we think about the left neighbor, how can we think about the right neighbor, how can we move from one state to other state based on the map that was given in the terms of Google. And this is what the challenge, like how can a system like a deep learning system can process voice? How can a deep learning system can process audio and video at real time is what the challenges of deep learning. So earlier when people try to design an AI system, they use it to process text. Then we have many applications which process voice, and now it is the era of deep learning systems to process the video. So we have many deep learning systems which process video. So that is the reason I kept like if Tesla has to go for a self-parking, what type of parking space is available, and what is the amount of space that is available, and what type of space that it needs, and a lot of predictions are happening at real time. So the same in line with what I have discussed earlier, we have kept an old expert system called as Mycin with almost 79 different versions, and a latest humanoid robot called as Sophia. Earlier, if you see the first version of Mycin as an expert system, Mycin used to collect various symptoms, and Mycin used to predict what type of disease that is attributed to that symptoms. This is a simple outcome that Mycin has earlier. But slowly what happened is it has almost 79 different type of versions, where the second version of Mycin, what it has done is it has taken the profiling of each patient, profiling in the terms of the history that the patient is having, and it has taken the DNA sequence of the patients, and it tried to based on the history that the patient has given, this Mycin used to predict what type of disease he is prone in future. And if you have 6 fingers in the hand, what is the reason for the 6 fingers? That type of analysis, this Mycin gradually has come into with all the 79 different versions. So if you have white hair in the head from the since born, what is the reason that you have white hair? If you should disable the entire right side of my body, what type of points that are vital to disable the body, and all these things an expert system like mycin can done. So 26th version of mycin, if you see, the doctors are using this mycin to prescribe medicines without side effects. So slowly, starting with the basic functionalities, this mycin expert system has now, if you see the website of WHO, the mycin can process the X-rays and CT scans of various patients, and it can also tell whether these patients are prone to cancer or not, or this COVID or not. So various versions are there, and every version will have its own usability, and version have different functionalities. So if you see the 36th version of mycin, you have some two functionalities that it identifies the protein coding region and promoter region in the body, and this mycin used to suggest what type of cancers that these people are in prone in future. And if there is a cancer, what is the stage of that also, if mycin is going to predict. So a Sophia, if you see this picture here, a Sophia is a humanoid robot, where in this picture, Sophia is taking a class for 8th class students. A Sophia is a humanoid robot. What is the interest that people who are working in artificial intelligence must have is like, how does this Sophia can interact? And based on the training that was given, how it is going to take this mathematics class. If you see the latest version of Sophia, it can also understand the sarcastic laugh of the students. How can Sophia process video at real time and can understand the meaning as well as the laugh? And how does the image processing that of Sophia is faster and instantly processing this video? So we need to understand, like, I need to have a deep learning system which process the video and can understand the colloquial language of the students, and to process and answer the queries that are posed instantly if there is an answer in the database. So for all the discussion for the last two slides that you see, like machine learning and artificial intelligence and neural networks, whatever the systems that we are going to develop and we have already developed, we need a database and we need data to have any of the machine learning algorithms to execute. So to conclude, what we said is like earlier when we tried to develop artificial intelligence algorithms or systems, we used to process text, but now it is the voice, it is the variations of voice in the terms of colloquial voice, or what type of English that he has, and what type of if we have an expert system in our lab where it will understand various types of Telugu. Whereas we have 16 different accents in the terms of Telugu, and all these accents we train the system so that it can understand that. So what type of colloquial languages that we have, and how can a system can understand all these things. So a deep learning system in general has to process text, in general has to process this voice as well as the video at real time. So these are various applications that most of the people are aware of. These applications, like this is a Hawkeye system, where a system which most of the people are aware that people are watching this cricket. So whenever this cricket was watched, so at real time, after pitching a ball, what type of deviation this ball can take, and what type of displacement, and what is the height that this ball travels after pitching is a prediction that will happen at real time. So Hawkeye, if the objective of Hawkeye is clear, but what is that we need to understand? We need to have a deep learning system which process the video and which calculate the amount of deviation and displacement that this ball can make after pitching. So what is the displacement, what is the deviation, what is the height that this ball can travel over the wickets once the ball is pitching. So this is prediction at real time. So you are aware of face regression is used everywhere. Earlier when we are doing our BTech in 1997, we used to have a language called as Prolog. We call it as an AI language. Then the image processing in 1997, 2001, 2002, even till now, people are doing it with MATLAB. Now, most of the image processing, if I am doing and in my lab, people are doing in the terms of Python. So we have different AI languages. We call them as R. We also have Python is also can be called as an AI language because most of the constructs of deep learning neural network are already there are in Python. So even MATLAB can be called as one of the AI language where most of the image processing can be done, and we have inherent libraries which supports AI system. Intentionally, I have kept this slide saying that most of the applications, whether it is a Siri, or Google Home or Alexa from all these are voice-based systems that interacts with people. If you see the kids that are interacting with using these mobiles, they interact with the system in the terms of voice. So all these are voice-based systems, like we can use them for searching. Many other applications are there based on the way in which you choose, whether it is Alexa or a Google Home or a Siri from Apple. So we have various applications in the terms of how the people will process this voice. And most of the cultivation, even though the drones are costly, most of the people now they are monitoring the crops by using these drones. So I have kept a drone where this drone is taking the pictures of the crop. And then what does this drone will do is this drone will integrate this input to a deep learning system. And in the deep learning system, we have a big database where the database consists of images of healthy leaves and diseased leaves. So based on the input that was given by the drone, this deep learning system will identify whether the crop is diseased or this crop is getting into ripe or so on and so forth. So if it feels like if the based on the training that was given, if they feel that this crop is getting into a diseased zone, it will tell you the intensity. This, if you see the website of Haryana, we have 5 different types of intensities: 1, 2, 3, 4, 5. 5 means it is this crop is highly damaged. So you have now artificial intelligence is not working in a single alone, but artificial intelligence now is integrated with various people. Like when we are trying to give the challenge, we are integrated with the speed gun. Here, deep learning system is augmented with a drone to take the pictures and then scan the pictures which are already there in the system and just alert the farmers by using IoT chip. So all these are the way in which the smart way. See, IBM Watson is a question and answer mechanism. You ask a query and it will answer based on various input that was given. So Google Map can be called as an AI system because based on various parameters, like if I wish to find the shortest distance between Bembaram and Delhi, based on various parameters, the traffic at this instant, the quality of the roads that we have, and what type of mechanism that you are using to reach that place, it will guide you to reach that place. So all these are AI techniques or AI applications that we have seen. So most of the people, like most of the deep learning systems or expert systems, the people talk about weather prediction is a standard application of artificial intelligence. So if I wish to find the weather of a particular place, in particularly Delhi, I wish to find the weather. So if I have the database for the last 2 years, I can predict what type of weather that Delhi will have tomorrow, that is on 16th or 17th. But the artificial intelligence, when we try to process the things, we have data called as a static data that is called as a database at this instance. But we need to also process some dynamic data, like example, consider the distance between the nearest cloud and the particular earth. If it is less, there is a chance that you will get rain. Precipitation, humidity, all these values will change with respect to time. So when these values will change with respect to time, if that parameters are also considered, then the AI system will be more robust. So a deep learning or AI system has to consider both the static as well as dynamic parameters. So static, most of the time we call it as a database. The dynamic means values that will change with respect to time. So if this precipitation amount, of humidity, and so on and so forth, if they are considered, then obviously we can just have a better classifier which people can rely. Most of the expert system that people talk about is a stock market prediction. Like assume that I wish to find out the variations of stock market in the terms of reliance. So if I know the stock market variations of reliance for the last 6 months, I can predict what type of values that what is the stock market value of reliance in the next day. Like tomorrow, what is the reliance price? If I wish to somebody ask me, I can just tell based on the variation that we have for the last month, I can predict what will be the reliance price tomorrow. But we don't think that reliance price only depends upon the static data. It depends on a lot of factors, like assume that Reliance, there is a statement saying that Reliance outlets are open in Hyderabad, Delhi, as well as Mumbai. They wish to open more outlets of Reliance. The stock market value may change. Or if there is a fake news saying that Reliance is going to close its operations in Delhi and Mumbai, then also there is every chance that the stock market values will change. I assume that there is a news article saying that there is a particular quarrel, or if there is a calamity or a quarrel in between Pakistan and India, there is every chance that the stock market values will change. My interest of telling all these things is like you have a static data with you. You also need to process the dynamic parameters that will change with respect to time, so that you can have a robust and versatile classifier, or we can call it as a system which predicts. So the artificial intelligence, when people try to design, just a minute, when we try to design these systems, what is that we need to understand is we need to process the systems. We need to process the systems in the terms of both static as well as dynamic parameters. Just a minute. So we need to have an AI system, and somebody wish to develop an AI system. We need to when somebody wish to develop an AI system and design an expert system, because most of the people when try to understand artificial intelligence, they will understand artificial intelligence in the terms of what is the ultimate aim of reading a subject called as AI. We will tell the students that we need to design an expert system. When we wish to design an expert system, we need to, in general, has to process static as well as dynamic parameters. When the number of dynamic parameters are more, then the usability of the system is more, and we can have a better predictor. People can rely on that system. So we spoke about IBM Watson as a question and answer mechanism. There are systems that for the last years, if you see the lab in IIT Madras, we have a crowd counting system where the target for this system is like what they do in this lab is they try to process these videos. The crowd counting systems are systems which automatically process these videos, and it will give a lot of information, like they will identify the people if the profiling was there, and then they will also tell you within an instance how many people are there in that video, and they will also give you how many people in that video are having some abnormal actions. So we can easily visualize the crowd counting systems as systems which process video. After processing video, what type of what is the outcome of that particular system is, after processing, they will tell you, they will identify people whose profiles are already there in that system based on the images. Like if they convert this video into a set of images, from that images, they will easily identify the people who are already stored in the database. And then automatically this will be done, and they will also find out the number of people who are already there. This is automatic. This is called as automatic surveillance system also in many of the papers that we have studied. So the number of people in that particular instance, if you say t is the time, like you say 1 minute, if it is there, the instance of video is there for 1 minute, how many people are there, and how many people in the video has some abnormal actions. Most probably the people who can damage the infrastructure, so on and so forth. So there are many definitions. In CC systems, we have 76 different types, where we, in a Curie project that we are doing for DST, we have installed a CC system in our lab, where the CC systems will identify the people, but it will also find the abnormalities. But what type of abnormalities we have tried is, like if somebody runs in a particular place, like we are a women's engineering college, where there is amount of security that was embedded in the campus. So a person who is running at some point of time called as ground, it is a valid action at that instance, but running in the campus is not a valid action. So we have identified some of the legal actions and some of the actions which are not acceptable at that instance. So we have identified the people with these abnormal actions. So a CC system as a system, again, I'm saying it's how do you process a video and how do you get the outcome in the terms of various aspects. So COVID-19 now is, we have almost 26 different types of COVID-19 prevention systems, where in my Vishnu campus itself, we have developed a system which will process the videos and tell how many people in the society are practicing social distancing norm or not, and how many people in that video they are having masks, and if they have masks, whether they have kept this mask properly or not. So we have a deep learning system that was already developed. It is just a replica of the CC systems, but the output is different. Like how can we have the dots? We call it dots means people, and we measure the distance between the dots, and if whether these dots are maintaining, or the people are maintaining this social distancing norm or not. And how do you process the face and identify the mask, and whether the masks are installed properly or not. We have our own systems, and even if you see outside also, we have 26 plus 2, almost 28 different type of systems are there in deep learning. So if you see the website of WHO, we have different types of software that are available. They can process X-rays, they can process the not only X-rays, various other output that pertain to the COVID. They process this X-rays and other infrastructure information. Then it will tell you whether this patient is prone to COVID or not, based on this various inputs that we get other than this X-rays. So I just started the lecture like this because most of the people will do that. AI is an integral part of our life, and most of the applications, most of the real-time problems which are having societal significance, you can solve the problem by using artificial intelligence. Even many problems in bioinformatics, like protein coding region identification, promoter region predictions. How do you measure the functionalities of a protein? How do you measure the structure of a protein in the terms of whether it is a ternary structure or a urinary structure or a binary structure of the protein by analyzing this DNA sequence or RNA sequence? Most of the things that are done manually are that can be done by using our deep learning techniques, because even we take a sample input as blood, we take blood in the terms of DNA sequence. So the input for this systems which process bioinformatics will be a DNA sequence or a RNA sequence. So input will be in the terms of AGCTs only. So, but we need to understand, like, if you take a DNA sequence like this, like if you assume that this is what a DNA sequence that was taken, but every time we cannot guarantee that the neighbors of G are C and A. So we need to predict what based on the time instances T and T plus 1 and so on and so forth. We need to every time predict who are the neighbors and so on and so forth. So if you consider artificial intelligence, most of the shopping websites, whether you use this Amazon or Flipkart, many of the shopping websites, even the offline shopping complex that we have, Reliance and so on, so they use this deep learning and AI techniques for a lot of, like, you procure something, like for the last 2 days we are trying to procure printers for the Department of CSE at Division Engineering College for Women. So whatever social media website that I have opened, even in Google, YouTube also, I am getting these recommendations for these particular printers. How can a system and how can a system can understand this type of preferences? Like, you have a box over system that people use in Google to sentimentally analyze the customer behavior, like what type of goods he has procured already and what type of goods he is particularly searching, and what is the goods that are to be suggested, recommended to him, because most of the people now they're working in this recommendation systems. How do you sentimentally analyze the customer behavior and try to predict his the way in which he procure things in future? So how do you recommend the systems? Like, I just try to buy a mobile, then what are the other recommendations that can be given? And that recommendations has to be feasible, and most of the time, even in the music, when we, what is, even when we try to think about music, the Spotify is an AI application that people are using now. And we need to understand what is the specialty of the Spotify to be highlighted and used. Earlier, we used to develop chatbots by using Ada language within 20 or 30 minutes. Now we are using the chatbots within 1 or 2 minutes by using Python. So you are aware that this ChatGPT was taken over the world. ChatGPT, it's now acting like an expert system, giving a lot of answers for many questions. So we use artificial intelligence in shopping. Most of the people now they are using. They analyze the sentimental behavior of the customer, and they analyze the review system and the feedback that was given in the customer, and they will find out what is the particular good in demand, in what time this particular good is in demand, and so on and so forth. You have many systems which do all these recommendations, or which do all the suggestions, which do the analysis and take some decisions based on this. So in just 2019, prior this pandemic has struck us, the government of India has started this e-challan mechanism in Hyderabad for 1.5 months, where this e-challan mechanism is also a very simple AI system, a deep learning system, where national highways have all these CCTVs that are kept, and this deep learning system is augmented with a speed gun. Whenever a car exceeds the prerequisite speed, this speed gun will ignite this deep learning system, and this deep learning system will collect the video of the corresponding car and they convert this video into set of images where they can try to extract the images. From that images, it will find the car number, and instantly it will send a challan saying that this is the amount of speed that was exceeded at this instance, and this is the amount that has to be paid, and this is the deadline. And surprisingly, this was done within zero 0.7 milliseconds. So this is an AI system. This is a deep learning system where this is automatic monitoring of CC footages with the speed gun. And you are aware of these chatbots. See, I wish to see earlier I have used. See, I just prior to this particular FDP, I started searching the website of Canara Bank, and there are a lot of chatbots that are installed. I've asked the chatbot like how can I have a loan in this Canara Bank? The question that they've asked is she has asked many questions like, do you have an account? If I have an account, where it is? What type of account do you have? And the basic information that people try to have, this most of the chatbots are giving, whether you open a website called Amazon or whether you use a banking websites, most of the chatbots are providing this particular data that are primary data that is needed. But now the chatbot functionalities are different. You have a chatbot called as Eliza. What is this? Eliza will have almost 12 different type of versions. The Eliza will interact with people in the terms of, it will ask many queries like, how was the day? How you are doing? Are you feeling great? So is your, what about your plans today? And so on and so forth. It will ask 3 or 4 questions. And based on that, this Eliza will tell you the mindset of a person at that instant. This is trained like that. So we have many chatbots with different types of versions and with different types of functionalities that we have, including this ChatGPT that we are witnessing, which was a significant application that I need to mention in artificial intelligence. So the other application that most of the people they are working is this RPA, robotic process automation, the bot for everybody. This bot is different, that bot is different. And many of the companies like Automation Anywhere, or UiPath, and Blue Prism, they're working in this. Like, if ordinary mundane tasks, whatever the mundane tasks that people are doing earlier, if it can be done as a bot, that will be better. That's what they said, and they call it as robotic process automation. Most of the people are learning this from UiPath or Automation Anywhere. A lot of trends are there. Whenever there is a societal significance, a societal application, there is somewhere we call it as a deep learning system or machine learning system or AI system where we have solution and we can solve it by using. So robotics, we have a robotic lab where earlier I was in charge of robotic lab in our system where we have almost a team of 16 members. 7 members are from the CSE department and the rest of them are from mechanical department. We used to create robots with minimum type of operations where the robot can walk and it can hold 2 textbooks and it can walk from one class to other class based on the directions. So all this are the applications of artificial intelligence that we have done. And in health sector, like I spoke about mycin and various expert systems. In various parts of health sector, whether it is IBM Watson or whatever system that already existing, most of the people try to have the profiling of the candidates, and based on the input that was given in the terms of profiling, they try to predict what type of diseases that these persons may be prone in future and so on and so forth. And navigation sector that we have discussed, like this Google Map and various places where we are using this particular artificial intelligence. So my intention of keeping these many number of applications are every application is unique. But if you understand the basic version of mycin, mycin used to interact with people in the terms of text initially. Later, now mycin is used to train to process voice of almost 56 plus different type of languages. Now, if you see the latest version of mycin, it is trying to process the video also. So we can send a video message and just can extract the expected advice from mycin. So earlier, when we have AI systems that are processing text, slowly most of the people are using this AI systems by the voice. They're using the systems and they're giving the input in the terms of voice. So it is that is the reason when we have written book in the terms of artificial intelligence and deep learning, we have a concept called as conceptual dependency, where what exactly this conceptual dependency will tell is like you can have a statement. You can utter the statements in English or Chinese or Telugu or Urdu or Arabian language. If the statement is having the same meaning, it has to be like the knowledge representation has to be same. So a concept like it is a natural processing. When we try to design this knowledge, when you extract the knowledge from the database, we say that if the meaning of the statement is same, irrespective of language that people are talking, the knowledge representation has to be same. So when the knowledge representation is same, then many expert systems can process, because expert systems, if you take an expert system with 6 different type of phases, all this knowledge acquisition phase and many other phases, you can have tools that straight away you can have them and use the expert system for your design. So my interest of discussing all these particular slides is people, when they start designing AI applications or deep learning applications, initially we process text, then we are forced to process voice as well as video also. Now, most of the AI systems which are in demand, or if even my students for PhD or most of the students in NITs and IIT Madras, people are working on how do they process the video. It can be automatic surveillance, or it can be various systems pertaining to a COVID or so on and so forth. So an AI system finally has to process text, process video, process audio as well as images. So this is, most of the people are aware of this. Like when we have a traditional system, we have set of input and we know the output. So we try to design an algorithm where it processes the input and give the output. But in artificial intelligence and neural network and machine learning, we trying to have a model which will fit this standard input and output. We call it as a data set that we are using or have used for training and testing. And most of the people ask me this informal. I say if somebody wish to implement artificial intelligence, they have to use either machine learning or they have to use this deep learning. So when the number of, I have only 100 images, and if I ask you or somebody to bifurcate these particular 100 images into set of animals, images pertaining to animals and pertaining to vehicles, it's very easy for us to have the properties, like to have the features of animals are different, features of vehicles are different. So obviously we can bifurcate by using machine learning algorithms. So if I have 1 lakh images, and then if I ask what type of particular animal it is it a cat or is it a rat, and what type of vehicle it is it a car or is it a auto or whatever it may be, then the problem is like what type of features will identify a car, what type of features will identify an auto, what type of features will identify a lorry, and so on and so forth. So the number of features will change to predict. Even the number of the data also will change. So that is the reason in machine learning will suffer the way in which you store data in the terms of systems. So in Arabic language, like if somebody asks me in an FDP saying that in Arabic language, if you wish to add something, it's very difficult. Because machine learning suffers, like when the number of data is more, the machine learning algorithms will give most of the time it will give a plateau like this. So when the data is more, the performance may not be more. And machine learning suffers with the way in which you store data in the terms of systems. Representation will definitely matter in machine learning. So in general, it's not a rule, but when the number of futures are more and when the data is more, in general, we ask the people to go for deep learning, that is deep neural networks. So all these things, this is the overview that I give. We have many different types of algorithms in machine learning. Some of them are supervised learning where the data is labeled. We have many mechanisms of supervised learning. And the data is not labeled. So we need to have some certain similarities, because in supervised learning, you know how many classes are there, you have the strategy. So based on some similarities and other factors, we have to bifurcate the data based on various constraints. We call it as unsupervised where the data is not labeled. Reinforced learning is learning with respect to taking a feedback, because we have a robotics lab where we try to design these robots. We use this particular reinforced learning. We try to create a hand for this robot and then perceive the environment, take the feedback, and what type of rotation that we need to adopt to this particular robot, whether it has to be a sideward movement or right and left side or right side, and what type of deviation it has to take. And this is how we try to have systems in reinforcement. They take feedback and move from one state to other state. I said we have different drawbacks in machine learning in the way in which when the number of the data is more, then there is every chance that the performance may not increase. And the number of futures to identify the object is more, then obviously machine learning suffers. Machine learning will also suffer the way in which it stores data. So that is the reason most of the time when we have more data, then better go for this deep learning. That's what it is, not a rule, but that is what we people try to have. So I'm not going to explain most all these things, but these are the standard supervised algorithms, and most of them, like if you consider this linear regression, it tries to apply relations that will predict the output of events based on some set of independent data points. You are already aware of this. We have a lot of advantages of linear regression, like if it is a linear data set, almost you will get the prediction accurately. And it's very easy to train, as well as it will not warp it. So a lot of advantages are there. Some disadvantages are like assuming the linearity itself is a big disadvantage for this linear regression. And there is every chance that it is prone to noise, as well as there is every chance that overfitting can come. And outliers, it is very sensitive. And a lot of other algorithms are also there in the terms of random forest and so on and so forth. A supervised algorithm is, I said, like supervised algorithm is an algorithm where the data is already labeled, so you apply a classifier. And most of the people, when we start this type of research on machine learning, we use this random forest. And if we see the random forest, the way in which it works is, we need to understand this ensemble. Like when we go for an ensemble, you have two types, like bagging and boosting. Random forest is used for both classification as well as regression. Many advantages are there. Like you also have a disadvantages for this. Advantage is like the problem of overfitting that we have seen in the earlier case will not be there. And it is having a lot of disadvantages also, like it is very highly complex, because the strategy that is, we can assume that random forest is a collection of simple decision trees. Our random forest can be thought as highly complex compared to a decision tree. And even random forest, the training time is more because due to the complexity. And whenever we need to predict something in particular random forest, we use these two algorithms like bagging and boosting, and standard algorithms like ADA boost, XZ boost, GDEX boost, and so on and so forth. So all these are supervised algorithms where we try to discuss this when the data is labeled. And we also have unsupervised algorithms like k-means, a priori algorithm, hierarchical algorithms, where the data is unlabeled, and like in k-means algorithm, k-means is an unsupervised learning algorithm with clustering data points. And what it will do is this algorithm iteratively, what it do is it divides the data points into several clusters in the terms of k clusters, and it tries to minimize the variance in each cluster. And we have many advantages when the large data sets are there. We go for this k-means algorithm, and see, if you see the convergence point of view, it guarantees this convergence and easily adaptable to a new examples also. But it's very difficult, like what are the values of k that we need to identify. And the clustering data of various varying size and density, it's a big problem. And clustering the outliers is a big problem for this k-means algorithm. And the scaling with respect to the number of dimensions is also a major disadvantage for this k-means algorithm. I'm just not trying to explain all these things, but these are all these things that we have in machine learning. And this is what I said, like when you have a set of data which is more, when the data is more, most of your machine learning algorithms, you will have a plateau like this. So you will have the performance which is static. But when we go for a deep learning algorithm and data is more, the performance is more. That is the reason I said better to go for deep learning when you have huge data. So these are the various examples of deep learning models. We have many deep learning models, like if you have sequential data. See, I wish to process text. I can go for recurrent neural networks. So if I wish to compare the text, then if I go for this extension of RNN, we call it as LSTM, long short-term memory. So I wish to process, that's what I said, talking about a drone system where we have developed like a crop disease prediction system that was developed in CNN, where we try to get the instances or images from this drone. We compare the images that are there in the system and that are collected by the drone, and we just try to find out whether this crop is in yield, or whether the crop is prone to disease, or if there is a disease, what is the level of the disease. So if I wish to process images, then I will go for this CNN algorithm. And we are aware of this JAN, RBM, and DBN. There are different types of deep learning models that we have. And based on the input and based on the need, see, I wish to process videos. And then we have different versions of CNN in the terms of pooling layer and the filters that we have for CNN layer. With respect to the input that we have, with respect to the quality, the like, see, I wish to process a video, then I can have a CNN algorithm. I wish to process a text, I will go for RNN. Even LRU also, see, RNN, LSTM, LRU, all these are some. Now people are talking about a Terra neural network, which is an energy efficient system. And all these are deep learning models. So even my interest of the talk is like, what are the applications of deep learning? These are the references that you have said. And and most of the images are taken from the Google. I have not cited them. That is the reason I have kept this disclaimer. Thank you very much for giving this opportunity. And most probably in the next week, my textbook on deep learning for deep learning applications will be released from Pearson Education on 26th of this month. And most of the discussion initially that I have done are from the chapters. If you have any queries, please unmute yourself. We'll have a discussion, please. Sastri garu, thank you very much for giving me this opportunity.
Thank you so much, sir, for sparing your time. So, dear participants, if you have any queries, so you can directly talk to me. So, someone has written in the chat box.
Yes. What do you think about the capabilities of AI in different sectors of our life, especially in health sector? And the settings will be able to remove totally many small and average jobs and careers in near future. It's really one of the major concerns of many people, people like this UiPath, or people from Automation Anywhere, or people who put into Blue Prism. They try to create bots for this mundane tasks. I don't think AI will replace the human existence, but there is every chance that to some extent there is a chance that we may be suffering with respect to artificial, because because you have an article yesterday that I read from Computer Express that was authored by Yashwant P. Kanitkar, saying that we have systems that are coming up which can think beyond the perception of a human being. That is also possible. That's what he said. So these statements or these systems can disturb us, but I feel like a computer cannot replace a human being in total. We can train the system to perform certain tasks. Thank you.
Yeah, thank you, sir. Anyone else? So meanwhile, I have shared the attendance link in the chat box as well as on the YouTube channel. So all are requested to fill the attendance. And thank you, Dr. Kiran sir, for coming and for sharing informative knowledge with the participants of this 1 week FDP on machine learning, concepts and applications. Thanks once again.
Thank you very much, sir. Next time, if I have an opportunity, what is the try do is I will come with a hands-on session that will be interesting for the participants. Like we have bots that are developed in our lab, and we also have AI systems that can be exhibited. Like we have a robotics lab. We have this crop prediction system which is integrated with these drones. And if the hands-on sessions were planned for these people, like that will be great. Next time when I have an opportunity, I will use that opportunity for giving a hands-on session, sir, because I was sure in that. Thank you.
Definitely, we will arrange that hands-on also for the participants. So once again, thank you so much, sir. So dear participants, this was the 4th session of day 2. And now we have 2 sessions tomorrow again at 11 a.m. and 2 p.m. I will share the details of the sessions in the WhatsApp group. Thank you, everyone. Thank you all. Good evening to everyone.
Thank you, sir. Have a nice day.
Thank you, sir. Have a nice day, sir. Thank you.